This is section 3.7, part 3, where we want to find the area of a triangular region. So, finding the area of a triangle. We all know the formula of a triangle is, the formula for the area of a triangle is 1/2 base times height. So, could you use this? Yes. But we don't know what the height is. We don't know what the base is. All right, you could use the distance formula and then maybe a little bit of trigonometry to find what the height is. But it's a lot easier if this triangle is given to you in a coordinate plane, because we can use the determinant of a matrix to help us find the area. So we're going to use our skill of finding the determinant of a matrix. So we've got here a triangle. It's in a coordinate plane. And we want to pay attention to the endpoints of the triangle. All right, what are the values? All right, what's the ordered pair? So, make sure I've got green. We've got a dot right here, right at the origin, so we can see the ordered pair is 0, 0. We can see the ordered pair here is 1, 2, 3, comma 2. And we can see the ordered pair up here is 2, comma 5. So we'll give these points. So we'll say point A is going to be 0, 0. So I've designated this A. We'll designate this point B, which is 3, comma 2. And we'll designate this point C, which is 2, comma 5. So there's a formula, all right, when you know the ordered pairs to find the area of a triangle, and I've got that written down here. So the area of a triangle is A, for the area, is equal to plus or minus 1/2 times the determinant of this matrix. So we've got the ordered pair x1, y1, x2, y2, x3, y3. So the first ordered pair, second ordered pair, third ordered pair. And to fill out our matrix, so it's 3 by 3, we're simply just going to put the value of 1 here in the third column. So notice the plus minus. All right, when you find determinants, we found that sometimes determinants can be positive, sometimes they can be negative, which is perfectly acceptable. But when we're dealing with the concept of area, it's really not a good idea to have a negative value, because it doesn't make sense to have a negative area. It's not feasible. It's not possible to have a negative area. So we want to always make sure we have a positive value as our answer, because, as I just said, it doesn't make sense to have a negative area. We want our area to be positive. So the plus or minus in the formula allows you to choose the sign that gives you a positive answer. So once you calculate your determinant, if it's positive, you're going to multiply by positive 1/2, because a positive times a positive is a positive. If your determinant ends up being negative, you're going to multiply by negative 1/2, because negative times a negative still gives us a positive. We want a positive value, so we have a positive area. So let's see what we can do. All right, so we're going to use our given points. So we've got A equals plus or minus 1/2 times our first ordered pair was 0, 0. So I've got 0, 0, 1. Our second ordered pair was 3, 2. So it's 3, 2, and then we're going to fill 1 in the third column. And our third ordered pair was 2, 5. So it's 2, 5, 1. We're first going to want to find the determinant before we go ahead and multiply by positive or negative 1/2. So going back to the last video, we know we have to recopy down the first two columns. So I've got 0, 3, 2, 0, 2, 5. And we're going to want to find this determinant by hand. So it's the first row, or the first diagonal, the product of the first diagonal added to the product of the second diagonal added to the product of the third diagonal. That's what we're going to do first. All right, so we know area is going to be equal to plus or minus 1/2 times product of 0 times 2 times 1 added to the product of the next diagonal, which is 0 times 1 times 2, added to the product of the next diagonal, which is 1 times 3 times 5. And we're going to subtract that from the products of the next three diagonals, which is 2 times 2 times 2 times 1. Add that to the product of this diagonal, added to the product of this diagonal. So we've got our next three diagonals. So we've got 2 times 2 times 1. The product 5 times 1 times 0. 1 times 3 times 0. And then I'm going to close my big parentheses here. So I've got big parentheses on the outside, brackets here, brackets here. So we need to simplify. So I've got plus or minus 1/2. Alright, and we're going to multiply that by 0 times 2 times 1 is 0, plus 0 times 1 times 2 is 0, plus 1 times 3 times 5 is 15, minus 2 times 2 times 1 is 4. Add that to 5 times 1 times 0, well that's 0. Add that to 1 times 3 times 0, which is 0. So we've got plus or minus 1/2. 0 plus 0 plus 15 is 15, minus 4. So we've got plus or minus 1/2. 15 minus 4 is 11. 11 is positive, so I'm going to choose positive 1/2. And so the area is 11 halves, and we want to make sure, since it's area, we're just going to write square units. We don't know what the units are, so we know we have to include units with area, so we'll just say square units. And that's how we find the area of a triangular region. Alright, given this area, we know it's 11 units squared.